Hello all and welcome back. So in this video we are going to continue our discussion on recursion and arrays and going to solve the question on the screen to check if an array is sorted, as the same will help us to better understand how to approach questions when we are dealing with list or array in a recursion. So let's get started. So the question is actually in front of us. The question asks us to check if an array or a list basically is sorted, but we have to do the same using recursion and have to also define a recursion relation, recursion tree, and of course do that same via head or tail recursion. So let us try to first do it and go to the code. So def check sorted. Let's say I will be getting a list which can be ARR, or let me make it L1. And for the timing, let me pass 2, 5, 7, 9, 10 maybe, yeah. So this works fine, right? So we will be checking if this particular list, we can see that it is sorted. We have to check the same via recursion, right? So let us break down this problem the way we break down each and every of, I would say, recursive problem. The very first one is the base case. So base case, as of now, I think I've already discussed in the last class as well, and I'm making sure that in this course I'm giving you lots of practical examples and then explaining the concept. So please make sure that you also solve and think in this particular manner only. The base case is actually when size is equals to 1 or size equals to 0. Because if you actually think about it, if the size is equals to 0 or 1, then for sure the array will be sorted, right? Like there is no way array cannot be sorted in that way. So we can just quickly write the same as well. So what I can do is, if my L1 dot length of my L1 equals 0 or length of my L1 equal 1, then I can just return true. Okay, so we should just print the same as well. So we get our answer. I can just return true. Now, if we actually think of the next step, it is on making the recursion call, right? Recursion call, or I would say your induction hypothesis or recursive call. I think it makes sense that I can ask my recursion to check if, so I hope you have done slicing very nicely, everyone. So we can slice our list like this, right? So let me just maybe just for the time being, what I want to show is, like, let's say if my list is 1 2 3 4 5, now if I print L2 of 1 and all this is gonna slice my list, right? So you will see 2 3 4 5. The reason for that is this is a 0 index, then first index, and what exactly is happening is that I'm just taking all the elements starting from first index. So this has been very nicely covered in the same, I would say, course in slicing. So please make sure that you see that once. So I will be sending my list, but will be removing the first element. So I am actually making sure that I am working on the first element, and then of course, yeah, like the recursion can take care of the rest, right? So let's say I get my answer here. Let's say I get my answer here because I'm returning something. So it's good if I catch the same as well. Now, if we pay attention, can we now return this answer? Can I return this answer? I think no, right? Because I have not done my work as of now. I have not done, or I have not checked. So for example, what would have happened is that in the recursion call, we would have sent these elements, and let's say it would have returned true. Now you don't have to question how you will get this as true. That is something which I have been stressing upon a lot. The same will follow in recursion with arrays as well, arrays or list as well. You don't have to question. Once you have written and made this call, the beauty of the framework, the way I'm explaining you, you don't need to question that, you just need to write your logic. Now, if your answer is true, right, that will be, still you need to check for this first element. Okay, still you need to check for this first element. Now, in the case when this is 2, of course, your whole array is sorted. But what if this particular element is 10? Then of course your answer should be false, right? So, and to just show you what the problem will be, we just return it as of now. Let me run it. We are getting it as true, and if I run it now, we are again getting it as true. So it is saying that yes, this array is also sorted, but I think we can see the same, right? This is not sorted at all. So what exactly we have to do is we have to also make sure that we are doing our work as well here. So if L1 of 0, okay, so I'm just thinking in terms of this list, the list which I have. I don't care what recursion would have done. Let me first write the code and then we can think on that, okay? If this is less than the first element, if this is less than the first element, then I can just return whatever I'm getting the answer, right? I can just return whatever I'm getting as answer. Else I can return false. I can return false. See, I can write else here. That would be helpful. If this is true, if this is actually happening, and you can just check for equal to as well. I'm taking strictly sorted. So if this is 2 and 2, it is not sorted in my term. But if the question requires like that, then you can put equal to here as well. So it is returning you the answer, right? It is returning the answer as it is, because see, this is true. It won't have an effect. If the answer will be true, then it will remain true. If the answer will be false, then it will remain false. Okay. But when this is not true, then of course my answer is surely going to be false, right? So that's why I'm returning false here. And now this code is going to work perfectly well. But first let me actually write, and first let me actually make that recursion tree, and then it will be making sense to check for this, right? So let me make the recursion tree for you now, everyone. So this is actually going to be my array. This is going to be my array. 2, 5, 7, I think it was 9 and 10, right? 2, 5, 7, 9 and 10, right? So first I'm making a call, but this time I'm just sending 5, 7, 9 and 10. In the next, I'm also again making a call. This time I'm just sending 7, 9, 10. Again I will be making a call, just sending 9 and 10. And finally, one of my last function is going to just get the element 10. Now when it gets the element 10, I have written in the base condition that you are sorted, right? If you have just a single element, then for sure it makes sense that you are going to be sorted, and it's going to return true. Now this second last function, what it's going to do is, it's before returning the answer, the way I have written my logic, right? The way I have written my logic, and I'm making this all on the notes so that you also get this and you are better able to revise everything. The way I have written my logic, it will, before returning this answer, okay, or before even changing this answer, it's going to check if L10 is less than L1 of 1. In this particular case, this is the list, and 9 does seems to be less than 10. So it's actually also going to return true only. Now this function is going to check for 7 less than 9, because this is 0, 1 and 2 here, and it's going to return true again. In a similar fashion, you can see that 5 is less than 7. So this is also going to return true. And now finally my 2 is less than 5. So it's also returned as true, whichever I was getting, and the final answer is true. Now again, I didn't think of any of this while I was writing the code. I just made my problem smaller and assumed that recursion is going to work fine. And I am able to write the code perfectly well using the same thing, and you can, as you can see on the screen, right? As you can see on the screen. So if I'm running it for 25, 7, 9, 10, it's going to be this way. Now you can just quickly think that if this is 20, if this 20 is here, then of course this condition will fail and I will be sending false. If let's say this would have been 90, then I would be sending false from here, and basically what would have happened is that each and every value would have been false only. Okay, so it will be returning false, false, false. The false would have propagated towards the top. Okay, so I hope this is clear. Now I'm just going to copy this whole function and make your understanding a little bit more better. Okay, so check sorted 2, I am writing it. Now just one thing I want to actually understand is that, don't you think that if let's say the case was, if let's say the case was something like 25, 7, 9 and 10. Now don't you think here that you should first do your work, because let's say if the first element is not only sorted, the first element, this 20 and 5 is not only sorted, why should we make function calls deep down, I would say, to all the method, all these functions? Let's say if this would have been 1,000 long array, right? 1,000 long array or list, you would have created 1,000 such functions. Where's the first and the foremost? Like, you are able to see that, hey, this is not sorted, but still you are waiting for everyone else to get the answer. So what I'm actually kind of trying to explain is that in this particular case, as I've already explained to you that we can also do our work before, and for this particular question, don't you think that we should do something like this? So what I'm telling you is that we should first do our work and check. So if my L1 of 0, if my L1 of 0 is less than L1 of 1, then this means that my particular case is sorted, right? This means that my particular, this point, the one which I have to take care, this is sorted, right? And if this is sorted, then I can return check sorted to L1 1, right? So I'm just asking that, hey, I have checked for myself, this is sorted, please just get the answer, okay? And if this is not sorted, then I should be good to return false. So this is a little bit better implementation in a way that, and the reason for this is pretty straightforward, and I can show you that as well. So let me make L2 is equals to I for I in. Again, this is I think you have an idea, this is list comprehension, so pretty sure that you've learned about this as well. Okay, so range okay, so let me just show you what L3 is. L3 is a very big list starting from 10,000 something. Now see, if I send L3 in this particular question, if I send in my check sorted, if I send L3, okay, let me just yeah, I'm getting that recursion depth is exceeded because it will be trying to make 10,000 such functions, right? This thing will be making 10,000 times. But if on the similar side I call just check sorted 2, it's going to give me the answer. The reason is that I'm making sure that I'm able to do my work first and I'm able to handle such large input as well. The very first one is of course not sorted. It's 10,000 and then 9999. So it's going to return false in the very starting only. It doesn't have to create all those functions. Okay. So this is actually the very good implementation. You can even make it a little bit more better. So you can just check if it is going to be false. You can just check if it is not following this particular thing. And then you can just help and use call this particular thing on this like this, right? So proper use case of tail recursion where you are just calling this, okay, without any accumulator or anything because you're returning this answer. But yes, you are just called this, you have done all your work, you have checked for yourself, okay, and because you have checked it, you don't need to now do anything. Whatever the answer is coming, you can just return that. Okay, so I hope this overall understanding now, overall both and every cases are clear. So in how you can do the same thing. This is kind of a recursion tree as well. Okay, this is a recursion tree as well. To talk about the recurrence relation, it can actually be something like this. So recurrence relation is gonna be something like this, where let's say to check sorted, okay, check sorted a particular L1, what we can do is we can just write L1 of 0 less than L1 of 1, and we are going to call check sorted on L1 and the rest of our list, right? So this overall basically is kind of a recurrence relation, and the above is like, of course, we can draw the nodes in circle form and this will actually tell you a tree. Again, here just the call is getting made in a single, I would say, direction, so that is fine. You can draw it like this as well, but you should actually be able to understand. And after understanding, you should see that, okay, if you can able to write this in a tail recursion for if you're able to actually follow this, or you can do some optimization or not. So that is what my overall expectation from you will be if you are trying to, I would say, code this kind of a solution. Again, they are easy question as of now. Yes, we can do them via iteration as well, but I want to make sure that I first hone your skills on these kind of questions, so that when we will be discussing difficult questions moving forward, you will be actually feeling them very easy because you have kind of learned, I would say, recursion in a very step-by-step manner. Okay, so great everyone, I hope this is clear as well. In the next class now we are going to discuss another question. I'm going to help you to do another question in a similar manner, and that will help you in understanding recursion with list or arrays a lot better. Okay, so thank you very much everyone. Let's meet in the next video. Thank you.